Hello and welcome back to our tutorial series where we will set up a more complex garment coming from Clo, and we're going to use the Carbon Clo garment processor in Houdini. So let's get started. I'm going to create a SOP network, so geometry. Let's name this simulation. Alright, go inside and add a file node. Alright, let's bring in all our objects. We got the avatar right here. Let's maybe just hide some of the shading. I don't like the specular. There we go. All right, next up, another file. Let's bring in the next meshes, and we got, where's our obj? Start meshes.obj. There we go. We can see they match the avatar nicely. All right. Next up, we're gonna bring in our render meshes. Untick this one, and there we go. Render 2D. FBX. There we go. Took a bit longer because it's got 2 million items, 2 million triangles. And oops, another file. And there we go. Make sure it's selected this time. And render 3D. There we go. And the render 3D should basically overlap with the render 2D. There we go. Perfect. All right. Let's have a look. Render 3D. Let's put this aside because that's for the buttons and for the backhaul later on. But we want to prep our render 2D and split it into render mesh, so render panels details, and stuff we don't need. So our buttons here we don't need, for example. All right, let's add a split node and see how we can split it. All right, what have we got here? We got a bunch of names. So trim. Let's have a look at trim and maybe put a star here and see if you can get all of the trims. There we go. That looks like all the trims. Perfect. Well done. Let's add a null node here. And we're going to call this details. Next up, we have the rest. Let's have a look here. All right, what's part of the rest? Well, it's our panels and it's all of these buttons. All right, let's see if we can do another split. Just copy paste split. I'm just gonna put it in here. There we go. Delete it now. And what are we gonna split it by? Let's see. What have you got left? We got pattern, pieces. We got material options as well. We got some fabrics and we got some material something here. Oh, look at this. Material something. There we go, and that looks like all of the buttons and pieces. So if we put a null here, let's call this RBS for the rigid bodies, and another one, the second output, and there we go. That will be the render panels. So for the splits, you usually just have to sometimes try to see where you have like groups and how to best split things up, but it's relatively obvious usually. All right, this looks all good. Remember from the basic tutorial, all these render panels would have a center of 20 in set. That's just how Clo exported. So what we can do is just move it by -20. I'm gonna add a transform. And where are we going to put the transform? Actually, before everything. So we want the details and everything transformed. So go back here, set the translate to -20. There we go. And so our panels now, the center is basically around 0. Perfect. All right. We can press LH to lay things out. We got our start meshes. We get our avatar. Render to the side here. Let's create a garment processor. Did I type something wrong? Let's try it again. Garment, there we go. Processor, Clo, unwelded. And also I like to press Ctrl S to just save. All right. Let's now see, what do we need in the simulation? And later on, as of the t-shirt, we need in the simulation setup a material. So I'm just going to create both of these nodes. Carbon simulation. And just as before, let's increase the subdivisions. The length scale needs to be adjusted because in centimeters. And I think that's all fine for now. Maybe add another 0 to the linear motion, just get it out of the way. All right, cloth material. Carbon cloth material. All right. Again, we're in centimeters. Let's make this one a millimeter thick. Let's make it a bit stiffer. I like to increase the viscosity to 2, also the bend viscosity to 2. And it's a trench coat, so maybe add a little bit of viscous damping, make it 4, a little bit more rigid. All right, there we go. Let's bring stuff now into our garment processor. We got our start meshes going right here. What's up next? Render panels, we got them here. And where our details go on the third input. My blue flag on it, LH, just to sort things, and we get the error message, which looks very cryptic. Is it loading up? There you go. This looks very cryptic when you see all of the stuff, but you're going to see something saying Python. So this error message comes up when you don't have a name attribute on your start mesh. We don't. You can see there's no primitive name attribute, but we can create one from the primitive groups. So there's simple no called name from groups. Perfect. We just want to change the group mask just to a star, take it all. And now if we put our blue flag on this, we can see there's a name attribute of 30 unique names. And we're going back to the garment processor, and let's start setting the simulation here as well. Garment simulation, and we point to the XML file, which is our start meshes metadata file. And now our errors are gone, and we're good to go. All right, let's press create creases now. This will create all of the creases using the metadata. Perfect, there we go. All right, quite a bit, 170. Next step, geometry setup. We're going to press create geometry setup. We will also run the carbon remeasure using information from the metadata file. And since we have a decently high tessellation, this could take a minute. So just bear with me and go. And in the bottom here on the status bar, you can see a timer running. So you know it's not frozen. It's still going up 8, 9, 10, and so on. It says what it's doing. Is the remeasure being busy? And we're just going to wait for this to be done. So this might be another 20, 30 seconds. Just see how long it takes. But usually it's decently fast. And here we are. It ran through. It took about 45 seconds. All right. Now we got our simulation mesh tessellation that is very friendly to the carbon anisotropic model. All right, next up, simulation setup. You point to the cloth material now, which you already created. Maybe press Ctrl S to save where we are. Let's create a simulation subnet. All right, one thing I should have mentioned, or we can check now, is that you want your allowance to be roughly the same size of the triangles or quads. And here you can see our allowance extrusion, and you notice it's roughly the same dimension as the edges on the triangle surrounding it. So that's fine. We do not need to adjust the allowance. If you had to, for example, if there was a much finer resolution, you have to adjust this just to be in the rough ballpark. But right now it looks pretty good, so we don't have to mess with this. All right, we got our simulation set up, but let's hook it up to simulation. I'm going to add a merge now because we obviously add the collider as well. And then where's our simulation node? There it is. Let's bring it in. Wait a second for the simulation to initialize. There we go. I'm going to put this to the side. And where's our avatar? Here's our avatar OBJ. I'm going to make a collider out of it. Carbon collider. Perfect. We're going to hook this in. I'm going to swap this around because I wanted as first input. We are in centimeters, so the thickness, let's just change it to 0.1 as well. Reset the simulation and see what it looks like. There we go. Do we actually need all of those details on the avatar? I don't think we do. So we can just change the primitive group on the avatar to the body only, and also we're not animated, so let's untick animated. Let me reset the simulation, and there we are. Perfect. I'm going to save now. Let's just see what happens out of the box. Let's press play. All right, I can immediately tell the belt is a big problem. The belt grew and now it's falling under gravity. And also there seems to be some issues down here, but one thing at a time. Let's go back and deal with the belt. All right, figure out which of these pieces is the belt. How can we do this? Well, we go on name, go on select, and we change here select to, we keep it either on group or name because we have both available. Let me just hover over this and I can see the belt is piece 26. So we can just bind piece 26 to the avatar. All right, let me undo the selection view, go back here, and create a binding. All right, carbon binding, and we name it carbon binding belt. Our parent is our collider 1, and then our child is our belt number 26. Cloth point group, we can just set the point group to star, which means all of the points of the cloth will be used in this binding. Furthermore, I usually try to get the radius out of the way. Radius of 0 is prone to cause a lot of issues in over-constrained situation, so get it out of the way as much as you can, and control it via stiffness. All right, let's have a look at the simulation. Reset the simulation and go. All right, so that's holding the belt in place on the avatar. Let's have a look. There we go. But we can see a wavy thing on the belt. Well, where is this coming from? This is probably coming from then being an elastic on the belt in Claw, because we can see there's way more material now than needs to be, but we're already working with the references from Claw, so it must be something else. So let's jump into Claw and have a look. Okay, so we're back in Claw quickly just to check on the belt properties. If I click on the belt, I can see that we actually have a difference in the shrinkage. Weft is 100, and so no shrinkage, and warp is 50, so 50% shrinkage. And this is not the case for all the other ones. All the other ones have 100, 100, similar to this middle piece, 100, 100, but the main belt is shrunk 50% in one direction, which obviously is the one that's going around the body. All right, let's go back to Houdini. Okay, now we're back in Houdini, and we know we need to apply a 50% shrinkage around the body. It said warp in Claw, but actually in Carbon, weft and warp are slightly different. So weft is this direction and warp is this direction. So we need to actually shrink in weft. Let's go material, create a copy of the original one. I'm gonna rename this one main, and then the second one elastic. All right, let's go down to elastic. I'm gonna give it more freedom in compression and extension because it's quite elastic. We're going to want to change the equilibrium. We do not want to change it uniformly, we only want it in weft. So we go to the weft warp bias parameters, change the equilibrium to 0.5. Go back to the main parameters and let's have a look down here. I also want to change the surface. Let's just get it out of the way, 0.2, and allow a bit of growth, 1.5. All right, now we need to apply this elastic material to the cloth. We go back into our simulation network. Go back to our material, go to our cloth number 26. And here we have pointing to material main, which is set on a garment processor. We need to override this now. So let's delete the channel and manually pick elastic. Go back to the simulation, reset the simulation. We're already in frame 6, let's go back to frame 1, reset the simulation, and let's run a few frames. All right, our belt is now sticking pretty tight to the character. Let's go back and have a look. But it's not necessarily holding actually the coat down. We want it to come in with the coat. So what I'm gonna do is I'm gonna bring it a little bit tighter. I'm gonna decrease the radius so it allows to go away from its position. Also, let's override the offset so it's uniformly around the character. I'm gonna set the offset to 1 centimeter so it allows a little bit of space for all of the fabric material that's under it. Set the simulation and let's have a look. All right, let's bring it tighter in and look quite nice. We can make the belt a bit stiffer or give it more viscous stamping as well to make it a stronger material. Let's change the viscous stamping to 20, the bend stiffness to 5. Let's have a look. Set the simulation and press play. All right, I like this more. Okay, I think the belt is fine now. Let's deal with the next issues. What can we see? There's obviously some issues happening down here. Let's see if they resolve themselves. They don't seem to. So we get wiggling here. You can see it's kind of crunching up. And here, oh, now we get even more movement. Okay, there's definitely something going on out here. Right, first thing you want to do is maybe look at the simulation parameters, if there's something we can do to improve it. I can see our scene frequency is 24 and our subdivision is set to 30. I would amp that up a little bit. For characters like this, or generally, I actually prefer set the scene frequency to 60. So 60 hertz. Each frame is a 60th of a second, so 60 frames mark 1 second. On the simulation node, you can see this reflected in the frequency, which uses a script to set to the timeline FPS. I'm also going to bring up the subdivisions to 50. Our solver internal frequency now is 3000, which is 50 times 60. Let's reset, run the simulation to see if that improves something. All right, that hasn't really changed much. Now we need to think about what could be causing these issues. And there are normally 3 main reasons. Number 1, collision. So things colliding with each other, being stuck in each other, either cloth in each other itself or the avatar. Number 2, over-constrained situations, where you have bindings and stitching, where it pulls cloth in one direction and maybe at the same time the other direction, and these constraints find. And the over-constrained situation always creates this like jiggling and wiggling and movement that you don't want. And number 3 is actually a combination of both, where neither of them necessarily would cause a problem, but a combination of both cause a problem. So the collision fighting the constraint. Imagine a constraint trying to pull a cloth into an avatar, but obviously collision fighting against it. Let's see if we can isolate the issue now. First thing we can do is we can see if there's self-collision going on the cloth that's causing it. So we can just go to the main cloth material. We can untick self-collide. And let's reset the simulation and run it again. I'm also going to press Ctrl S to save my scene. We don't need to simulate any further. We can immediately see there's a problem still. All right, let's go back to frame 1. I'm going to tick this again so I don't forget for later. Now we're going to remove all the collision from the cloth. I'm going into the simulation setup network. Here, I can now search for all of the cloths. I can do this by add filter type. Change this from carbon actor, which is the default for me here, and go to cloth. I can press select all. Now all my cloths are being selected. Untick activated in the collision tab. Go back, reset the simulation, and you probably want to change gravity to 0 because without a collider it would just fall under gravity. Let's reset, press play. All right, we probably want to hide the collider physics drop because now with no collision, our cloth is going inside a collider. All right, let's see if we can spot here if there's any major issues. Maybe we extract all of the cloths and have a look at them first. Okay, let's go here at the delete node. In the group, what I'm gonna do is I scroll down until I see carbon node type, which might be somewhere here. Let's give it a second. There we go, carbon node type, cloth. And I'm going to change it now to delete non-selected. This deletes everything but the cloths. Now I need to unpack. And here we are. All right. This is overlapping and not sure if we get some issues here. Let's just simulate a little bit. All right, there seems to be a little bit of crunchiness. So it's hard to tell. It's all coming together due to the reference animation, so that's an issue. But do we see anything popping on the first frame? Let's have a look again. It doesn't seem too bad. There's some crunchy behavior here, but nothing super major. All right, so that's good to know. What else can we do? Well, let's revert first what we've done. I'm going to go back here. Search again for all cloths, add filter, type, carbon, cloth. Select all and activate collision again. All right. Now I'm gonna go back to my simulation and I can see this again, so I don't need the geometry view anymore. Let's bring my collider back. Let's stabilize the collider collisions a bit more. Instead of double-sided, go to single-sided. We use a small outer fatness to make sure that there's not an issue, and we use an inner fatness. Maybe that's too small. So that's 0.01, so that's 0.1 millimeter, and we use a larger inner fatness of 1 centimeter. Let's see if that fixes the thing up, but probably not because I don't think there's any collider collision issues down here. No. Okay. So next thing, what we're going to do is we're going to go on the carbon garment processor and we're going to disable all of the creases. So this removes our crease nodes which enforce angles, and it also removes all of the mesh allowance nodes with actually extra mesh allowance, which allows us to then apply creases on formerly open edges. You can see all of these points here, part of the mesh allowance and stitching. I'm going to reset the simulation now. You can see that they all disappear now. So let's get this out of the way and see if there's an issue with that. We're just simplifying our scene until we get to the bottom of the issue. All right, we still got problems down here. Now, next thing, on the carbon simulation node, we look at the detangle option. By default, it's set to all. If you set it to none and you see better behavior, that usually is an indication that there's an over-constrained situation, because detangle should always make your simulation more stable than disabling detangle. The only case where disable detangle makes it appear like it's a more stable simulation is when your constraints fight your collision. Because in that case, your detangle would fight the collision even stronger. So by turning the detangle off, you're going to have less of a fight. Let's verify if this is the case. I'm actually gonna also revert my gravity because we have our collision turned on again with the collider. Let's play. All right, we can see already there's way less movement and it's much calmer here. So just to summarize, if detangle set to none is more stable than detangle set to all, that is a good indication that you have collision fighting an over-constrained situation. Well, which constraints do we have? Well, the only constraints we have are the stitching created from the garment processor. And how can we control them? Well, on the garment processor node itself. We go to simulation setup and we have our stitching parameters. These default parameters worked really well on the t-shirt where there were no issues. So by default, the compression is 0 and equilibrium is 0 to really bring those stitches in tight and basically a 0 distance stitch, and just a little bit of extension to allow for some wiggle room. Okay, this obviously doesn't work here. Now let's have a look at this button called Create Missing Narrow Filters. What does this do? Imagine you have 3 panels come together in Claw. Panel A, B, and C, and they all come together on the same top edge. So you would stitch B to A and C to A, and they would all be together. Now what this creates in the metadata and in Carbon here in the setup is a stitching and a narrow filter from A to C and A to B. But you have nothing constraining B to C, even though the same points come together all to the points of A. So actually the points of B and C will be fighting each other. And this specific case is actually covered when you press this button. Let's go ahead. It creates, in our simulation setup network, it creates a new subnet where it creates missing narrow filters that filters exactly these situations. So before we adjust the stitching, let's give it a last go and see if this solves the situation. And in a lot of simple situations, this is all that's needed. Okay, this doesn't really solve all of our issues, so it doesn't hurt to have the create missing narrow filters, but we need to do more. Let's go back to GUM processor and loosen up some of the stitching settings. I'm gonna now change some of this. Stiffness, let's bring it down. Add a bit of viscosity. We can keep our compression at 0, but we allow a lot more extension. Bring it to 10, just in case we have some very close to 0 stitching, so the reference will be very close to 0. We need to extend it by a lot. Sometimes you might even have to extend it to 100. In equilibrium, instead of bringing it together to a reference length of 0, we're keeping it at 1, which is how it was in Claw. Let's reset the simulation and press play. And we can immediately see that this brings us to our situation being very calm. I'm just going to let this run for a few frames, and we're going to have a look if this is still calm and looking good in a few frames. All right, I've created an end blade with 49 frames. Let's just play this through, and we can see it's actually really calm. There's no issues popping up. Okay, one last thing to do on the simulation setup is, well, we want to re-enable. We probably want to re-enable, it really depends on you, but our creases, because we disabled all of them. Let's press enable creases. This takes a second, all of them are ticked again, and if you reset the simulation, you will see that we will get our dots back from the mesh allowance. And there you are. Okay, let's press play to see if this is still stable. All right, as we can see, there's an issue right here where things are really fighting each other. This could be that there was just a turned tick box ticked enclosed that we haven't adjusted yet. So I'm gonna go back. Let's look in here. And we're gonna have a look at the crease and just disable a single crease. Were there any other issues? Well, it looks like there's a problem up here on the collar as well, maybe. All right, let's select those two and see what we can do. All right, back to the carbon glow garment processor. We have the guide visualization set to creases. I'm going to select, and we're going to select geometry groups. We can now pick out our creases. What have we got? We have crease 96. So when we hover over it, you can see the crease highlight here, crease 96, which probably was a turned one, which will cause a problem right now. When we go over it, there you go. And then we might have a problem on the collar maybe, or not. Well, which was it? This one up here. Crease 137. Let's have a look at crease 96, crease 137, and maybe just disable them. All right. Crease 96. Where is it? 96. Crease 100. What was it? 37? No. Crease 100. Yes, 37. All right. Let's just disable these two creases and have a go. All right. I'm going back to simulation node and press play. Sorry, reset and then press play, obviously. Reset first. Let's go. All right, we're not 100% there. We're clearly missing another crease. All right, what did we miss? Probably one here. Let me go back in. Let's have a look. Yeah, it's definitely in here. Okay, back to our garment processor. Back to select. Have a looky. There we go, that's probably it. Crease 126. And it's right here. Let's disable it. Go back. Go to our carbon simulation. And reset the simulation. Press play. Now this looks much better. This is pretty calm now. So what you can do is with this is either leave it disabled as it is if you're happy with the results, or you can tweak the angle to make sure the angle and the strength of the fold are giving you the right results. But I'm just going to let this play now and see if it's set up properly and calms down. Okay, this is pretty good, but let's compare to the original. The original looks like this, and when we simulate it now, we get what looks a little bit of a stiffer result, which means our bend stiffness is probably too strong. Let's go back to the main material, and I'm gonna reduce our bend stiffness 0.1, and let's give it a larger angle limit to 145. Let's reset the simulation, then you press save, and let's run it again. Okay, that's much better. You see, we do not get a lot of the thing puffing up, basically. We're keeping a crunchy look like it was originally. Go back to the first frame and then go forward a little bit, and that seems in a similar style to what it was. You can obviously fine-tune the parameters from here as you please. All right, back to the first frame. Okay, now that we have got the cloth simulation sorted, let's have a look at finishing up the simulation part by adding the rigid bodies. So where's the rigid body geometry? I got my render 3D here, and similar to the render rigid bodies in 2D that we actually don't really need, we need to split them out of the 3D. So I'm just going to copy and paste the split, attach it here. Let's go down here to RBS, and there we go. We have the rigid bodies in 3D. Okay, now what we need to do is we can pass them to a new macro, and you find this in the tab menu under carbon macros and the carbon multi-cloth multi-rigid body welding macro. All you need to pass it is a stream of cloths as a second input. So this one you can find from here, from the simulation setup network. And the first input is a stream of rigid body geometries, and each rigid body geometry must be in a packed primitive. So what we have to do is take this input and turn it into packed primitives, of each packed primitive containing the geometry of a single rigid body. All right, let's have a look. Now, right now, we don't really have anything useful that we can use to pack it, so we're going to have to create something. One thing we can do is use the connectivity node. This automatically detects which nodes or which geometry is connected and applies an attribute on it. What we need for packing is a primitive attribute, and we're going to call it name. Also, it needs to be a string. There we go. We can keep the prefix as it is. Let's visualize this. We can do this using a color node. Click on the color node, make sure it is set to primitive, and then color random. All right, there we go. And let's put our pack in between. And we want to pack using attribute name. And here we are. We have 24 packed fragments, and all of them are visualized in colors. Let's go in and have a closer look. Let me center with space and A, and it's hard to see the back and the front side because of the shading, so I'm going to turn the shading off. And we can immediately see that this button has like a brown grayish in the back and a bright green in the front. And similar, the other buttons all have a front and a back that are different colors, which means they're different geometries, which leads to me thinking the geometry is probably not welded. So we actually get two different buttons for each button. We don't want that. So let's quickly weld this together. How can we do that? Let's just do a fuse, which will weld by proximity. And we can just use the default parameter, and it immediately updates everything in the graph stream. And here we go. Now each button has its unique color, front and back. Perfect. So, and also middle mouse button, click on pack 1. We see we're down to 13 packed fragments. Okay, one thing we can now think about is if we actually want this middle piece to be 1 or 2 rigid bodies. And I think I prefer it to be 1 instead of 2. So this buckle, the round piece and the cross line here, I think we should turn it into 1. Well, how can we do this? Pretty easy. Let's go to connectivity, and remember we have the name attribute. If I go here, select, and then name attribute, hover over it, I can see this piece 12 and piece 11. So what I need to do is just to make sure that piece 12 and piece 11 actually get the same name. All right, so how can we do this? Let's do a primitive wrangle. And I can just take piece 12 and then change add name equals piece 11. Oops. Let's have a look. Color, and there we go. Now we can see this has the same color, and we're down to 12 pack fragments. All right, that's much better. Let's take this, maybe move the cloth materials out of the way. We can select these. If you press L, it will lay this out automatically. All right, let's attach now the pack into our macro. I do not need to pass the color. I'm going to press S, Control S for save. Let's change the viewport view back to a shaded view. There we go. All right, we got the macro, put our blue flag on it, and now we just need to press this button. It has automatically created a network in here with the rigid body macros for each of the button geometries or the rigid body geometries, and a welding for each of them to connect to the underlying cloth. Let's just hook this up onto the simulation stream, reset the simulation, and see what we get. And here we have our rigid body macros. All right, I'm gonna press play now. Let's see what we at. All right, a couple of things we can see is, while the buttons here on the bottom cause a few less issues, we definitely have more issues with the buttons up here, which are intersecting with the cloth geometry. So let's fine tune the parameters of the rigid bodies and the weldings. And also let's see if we can change the start pose of the buttons, because the way they came out of flow, they were already intersecting with the geometry, as you can tell here in the start pose. All right, let's dive into here, and we can select all of the weldings. There we go. First of all, I would increase the radius. A radius of 0 makes a very stiff attachment, and we want to give it a bit of leeway. We work in centimeters, so changing this to, let's say, 2 gives us 2 centimeter leeway. Let's reduce the stiffness a bit. And that's fine. Count 4 means that our button is attached to the 4 closest points on the cloth. Maybe we can increase this to 6 to give it a little bit more stability. All right, now we want to look at the macros. I'm going to copy the name of one of the macros, go into search here, and obviously remove the number, and now shows all of our macros. I can select all, and now I can edit parameters for each of them. Currently the thickness is set to 0.001, and we are in scene unit centimeters. So this would be 0.01 millimeters. This is not good. So let's reduce it. And now we have a thickness of 0.1 centimeters, which is 1 millimeter. Perfect, much better. Also the mass, currently the default is 0.001. This is in kilogram, no matter the scene scale. So this would be 1 gram. I'm just going to up it a little bit to 3 grams to give it a little bit more heft to the buttons. Okay, let's go back to the simulation, save our scene, reset, and see if this already makes a difference. You can immediately tell that the physics draw has updated and we got a little bit more buffer around the geometry. Let's run this. Okay, and we can tell that we definitely have some issues with some buttons disappearing in the cloth. This is probably because they are already in the starting position inside the cloth, as you can tell here. So the simulation is kind of struggling to resolve this. What can we do? Well, we can just edit our button geometry to slightly move them out of the way. Okay, what do I want to do? First of all, I want to take the start meshes and show them. Just gonna merge this with the buttons geometry here. Bring in the packed buttons, merge, maybe put a color on the start mesh. All right, now I can see much more what's the start mesh and what are the buttons. All right, let's go ahead and add an edit node here. And let's edit some of the buttons. Okay, I'm gonna go to select this one and then T to transform. Now we can move this button out. There we go. Not much, just enough so it doesn't intersect anymore. All right, let's have a look at this big one. S for select, T for transform. Or we can R for rotate. Let's rotate this one a little bit so it's right here in the center. Looks nice. Then T for translate. Let's bring it up a little bit. There we go. That's much better. All right, next button. S, then select, and T for translate. All right, let's push this one out a bit. Maybe a bit over. That's much better, isn't it? All right, I'm going to push it out a little bit more. Okay, next one. S for selection mode, select it. T for translate. Bring it out a bit. There we go. This one I think is good, but I'm just going to bring it out just a tiny bit to be safe. Next one. And just rinse and repeat. Bring it out a little bit. This one here. Bring it over a little bit and out a little bit. There we go. Did we miss anything? Let's go up. That looks good. Well, we missed, there's one button actually hiding under here. All right, let's see if we can actually do this one too. All right, we're gonna wiggle it over a bit. Bring it out front. There we go. That seems to have fixed all the overlaps of this. All right, button up top, also looking fine. All right, that's good. Now, if you want to go over the top, if you go into the macro setup network, you could take the original unedited geometry and pass it as child reference meshes in here if you want to preserve the original button attachment positions. But I haven't moved them very much, so I think it doesn't really matter too much in this situation. All right, let's make sure our edited geometry is being passed on into the graph. So change wire here, and there we go. Now that's being moved in there. Let's go back to the simulation. This is the old view before we reset it. Now let's reset the simulation and see what we get. All right, this looks much better, but the buttons are now not stuck inside anymore. And we can run the simulation now. Maybe press Ctrl S to save, and let's go. That looks much better. The buttons are attached, but they're not intersecting with the geometry, and we're getting quite nice results. Let's pause and zoom in. There we go. Let me go in the camera mode. And that's nice how the buttons and the buckle are all nicely here set up on the surface and hanging out. That's neat. All right, I think this is enough for the rigid bodies. Okay, what do we have left to do? We have the render meshes left to do. Let's get started with that. Let's go back to the first frame. There we are. And now we go back to our garment processor unwelded. Give it a second to just recalculate everything on it. There we go. And we have our render meshes and details coming in. So what we need to do is go to our detail mapping tab. Press the button create mapping because we don't have mappings in here. This will create a mapping between the details and panels, automatically trying to match them by proximity. If you press create mapping, it's going to take a second to create the internal mapping. Okay, here we are, 531 details. And if you look at the incoming geometry, this already dwindled down quite a bit. All right, let's see how we can visualize the mapping. We go up to the guide visualization, and from Creases, we change it to mapping. There we go. This now shows us the 2D view, and all details will be matched onto the panels, and you will see the color matching too. So I'm just going to zoom in here, and it's hard to see, and there we go. We can now see the stitching, for example, here, the detail is in pink, same as the panel. So what you really want to look out here is just have a view through it and see if there's any colors that are mismatching. So for example, green stitches on the red panels or so on. But this all looks good, and I didn't expect anything else because mapping in 2D here is actually pretty easy and pretty safe choice. So we can just untick color panels if you want to. Next up, since we're happy with it, we can go to Mesh Deformer. We can create the Mesh Deformer subnet. I'm going to press OK now. Okay, here we are. That took about 15-20 seconds to create a Deformer subnet. Right, and here what we get is for every major panel, we get a network. So for panel 1118625, we create a Deformer setup, and then if you zoom in for piece 20 and so on. So if you get in any of these, we see a main deformer that deforms the main panel here. So we got our simulation result, we got our flat render panel in 2D, and we got our reference panel in 2D. So the simulation reference panel. And then we also have all of the details that have been mapped to this specific render panel will be stored in here. And then there's an extra deformer that deforms the detail based on the render panel. Here we can see there's nothing coming in, which just means that there's no detail assigned to the specific panel. All right, let's go back up. Let's have a look. Here we are. And if you press play, it will now deform the render meshes based on the simulation results. Well, let's bring everything together. Let's add a merge node, attach this to here. Then we obviously want to attach our avatar. Where's our avatar? There we go. Let's put a flag on merge, and we have our code and our avatar together. And we want to get the simulation results for the rigid bodies. So we can just go back to our delete here, and instead of deleting type of cloth, let's scroll down. It's going to be a second. There we go. Instead of carbon cloth, we go body. Remove cloth. And go to the unpack. And there we have all of our buttons. And if I scrub here now, you should see that these are the simulated button results. So we can also add this to here. Merge. And here we are. We now have our buttons, well, our rigid button and the buckle. We have our original avatar, and we have our fig garment. As you can see when you scroll on here, we got the fig meshes, the fig render meshes being simulated. Yeah, and that's basically the whole setup. Obviously, I didn't pass in any of the rendering, but if you want to set up your shaders and everything, this is what you want to do it on, because you have your fig, beautiful render meshes. Yeah, and here we are, and obviously you can clean up the scene if you want, delete some of the stuff, maybe organize and clean things up, lay things out nicer, But yeah, that's the setup, and hope you had fun, hope you learned something, and happy simulating.